Welcome. The following short presentation breaks down the costs and benefits of building affordable multifamily housing to Passive House standards, PHI and PHIUS. Both of these standards are included in the Sustainable Design section of the 2020 QAP and are eligible for 5 points. The presentation was developed by Paul Selnau for the Connecticut Multifamily Housing Peer-to-Peer Network, a group of affordable housing stakeholders focused on improving the sustainability and performance of multifamily housing across the state. The network recognizes that many affordable housing stakeholders may be suspicious of both the value and the potential extra cost of building multifamily developments to these advanced standards. The network appreciates these concerns, but suggests that they are, for the most part, unfounded. The presentation we have developed is designed to explain why and to suggest that current assumptions about the costs and benefits of building to these standards need to be reconsidered. Key takeaways from the presentation are: current additional costs for building to Passive House standards in Connecticut for projects that use Passive House principles in the initial design are between 3 and 5% of the current costs of construction, 2 to 4% of the total development costs. This cost differential is driven in part by a lack of experience or training in the Passive House design and construction process. Other states, specifically Pennsylvania, are seeing significant cost reductions in Passive House projects as more of them enter the development pipeline and teams gain more experience building to these standards. In fact, the cost to build Passive House standards in Pennsylvania is now slightly less than the cost of a conventional construction. Connecticut's costs to build Passive House are on a similar downward trajectory, but are a few years behind Pennsylvania in terms of number of projects built and, consequently, in terms of project team experience with Passive House. The network strongly believes that Passive House or other equally advanced standards should be the benchmark for affordable multifamily development across the state. This presentation makes the case that meeting this benchmark is not only achievable now, but will become increasingly cost-effective over time. Please enjoy Passive House costs and benefits. Thank you.
Thank you very much, Dean. My name is Paul Selnau, architect, certified Passive House consultant from CHFA Selnau Associates. Been involved in multifamily housing for well over 30 years and became a certified Passive House consultant a little over 4 years ago. And I've been involved in the design and analysis of several projects. And we've seen, and you've also heard from Susan's past presentation, that there's a shift in design philosophy from a prescriptive to a performance-based criteria. And it's very, very important that as we move forward, that we'll think about what we're really talking about here is true performance and how we're utilizing that to basically get to carbon neutral. So what we're talking about today is how do we save money doing Passive House, and what are the benefits? So one of the places to simply start out is that we need to start designing buildings that have a simplicity in building form. Now, that's not to say they're not attractive. That's not to say that they are a straight out box. There's a lot of interest in Passive House structures. You can see that. There's a lot of decks, overhangs, different shapes, things like that. But it's done very, very thoughtfully and very, very deliberately in a way that preserves the structure and also enhances the performance. But you need to start early in doing this. And by this, I mean at the very beginning of the project. If you try to fit Passive House into a building that you've already begun to design, that may be partially through schematics into design development or into construction documents, it's always going to cost more. So you need to start early, and you need to start with certified Passive House professionals, builders, and verifiers, because there's a wealth of information out there, and they all have the same interest in mind. They're coming from a different perspective, but they're all interested in sustainability and working towards a cleaner environment, which is what we're all trying to do here. So early, as I said, starts from schematic design, and that it starts when you first walk onto an empty site to determine what the best use for that site is and how that building is going to orient to that site and that environment. So to take this a little bit farther, this will both work for multi-unit buildings and townhouse buildings. We're talking about the same type of volumes where you're air sealing 6 signs of a volume. That's what we're doing. Whether it's an apartment inside a building or an independent townhouse, it can all be done, and it can be done efficiently. And we're also talking about realized energy savings and a return on investment that is much faster than Energy Star and other different types of programs. But in order to do this, you need to educate all the stakeholders. And that starts with a discussion with the client. Hopefully the client has come to you saying they're interested in this, but if they're not, as a design professional, it's something that we always raise and say, is this something that you're interested to consider early? And then that needs to be taken all the way through. So you're talking with the residents that are living there so that the building can perform as it's designed. And that's critical. And then the next step of this is verification and putting in systems into the building to verify what we have designed is actually working. All of these factors into saving cost. So when we're looking at a typical CHFA approved project and we're looking at one of the lower bars to reach, we're generally about 25% above the building code. We have our exterior envelope that is a little bit more efficient in terms of its insulation, and our efficiency and our equipment is a little bit higher as well. But when we're talking about a passive house building, we're 65% more efficient than the CHFA Energy Star standards and 90% more efficient than buildings designed by code. And this is really what we need to focus on. This is what the benefits are. This is where the money is being spent. And you can see from this that we're increasing the energy values of the exterior envelope and the efficiencies, once again, of the equipment. So based on a project that I've been involved with, which is roughly 58,000 square feet, what we're seeing, and this is also data that I've collected from a half a dozen other projects, that we see data coming in at 5% maximum, 3 to 5% increase in cost for passive house design. This particular project that I'm talking about right here is 4.79%. And we generally see 40% for material costs, 60% for labor. And unfortunately, what we're seeing is a 10 to 15% fear factor in many subcontractors who simply don't understand what's involved. And you can see that where we're putting a lot of this emphasis is on the envelope, on the added insulation. And in this particular project, as I've seen in others, the mechanical costs are actually under what the other projects are coming in at. So where is the money going? As I said, in a typical CHFA Energy Star project from this, you can see that we are putting 70% of our construction dollars into evolving mechanical systems. By evolving, I say systems that we were specifying and reviewing 6 months ago are almost becoming somewhat obsolete because things are changing so fast. Efficiencies are getting better. The system that I specified last year, I'm not specifying this year. So why would we want to spend so much money on evolving mechanical equipment? What you really want to be spending your money on is the building envelope, which remains static. It has a longer lifespan, and it is always going to be there because the mechanical systems will always be upgraded, changing, and with all these moving parts, they will always wear out sooner than your envelope. So this is where the emphasis is. So this is where the money is going. So let's take a look at exactly what I mean by that. So now here's a typical 2x6 exterior wall with an insulation that we always see. So that's no different, except we add a different material in there. There may be an increased cost. We have an exterior envelope, which always has a rigid insulation, but we're adding more. We're doing a lot more insulation around our window openings and our windows to prevent the thermal bridging that occurs from the outside in. And by that, I'm talking about the influence of hot or cold air on the interior environment. So that's what we're trying to control with that thermal bridge by adding that increase in insulation in the envelope. And this goes all the way right down the foundation wall, where we always have exterior slab insulation, but we have more. And in this case, we add more outside so that we eliminate that thermal bridge. And this continues, the same philosophy continues all the way up the wall and across the roof, where we always have had roof insulation, but we're adding more. So it's a continuous envelope. And as you can see by this red line here, this is what we're sealing. This is our air sealing area that we've always sealed per Energy Star. We're just doing it substantially tighter. So there's always been a discussion around mechanical equipment and the cost of equipment. And these are two side-by-side comparisons of two identical units. One that was designed by Passive House standards, which is this one on the left. The one on the right was not. So the one on the right is Energy Star compliant. You can see right here in the center, there's an air handling unit and a constant duct right in here, which is feeding air. And this is heating and cooling the space through ducts right in through here. In this location, we have a air handling unit, which is a little bit of a smaller increase in cost, but it is doing the same type of system, heating and cooling in there, but it's more efficient. So both systems have an ERV, an energy recovery ventilator. You can see here, this air is being drawn up right through this duct and into the system. But in a passive house building, it is ducted down into the corridor, comes into a manifold, and it is independently ducted into the room. So this is an added cost that you'll see for ducting, but this is where the difference comes in terms of ventilation. But what's interesting about this is that when you take a look on the right with a standard Energy Star type project, this happens to be a 40-unit building, we would be installing 40 different condensing units on that roof with upwards of 20 additional roof penetrations. We have an ERV, as I already stated, but when we're dealing with a passive house structure, we've taken these 40 units and we've condensed them down to 4. So there's a mechanical savings right there. There's an equipment and a installation savings that's occurring simply right there. There's a little bit of an added increase in cost by the way that the ERV is working, bit more efficient than your standard one for Energy Star, so you're going to see an increased cost of that. But as I said, in my current example, it's actually less. So here's some interesting data from the Department of Energy, where they actually analyzed passive house, Energy Star, and conventional homes. And you can see by this that the Energy Star is being surpassed by the passive house design. So we're seeing a 50% increase in quality of construction, comfort, and benefit for only 3 to 5% more cost. So, you know, if in fact you're going to purchase a new car, and the salesperson says, you know, I can give you a better car, 50% better car, I'm not going to charge you 3 to 5% more for it. I mean, wouldn't you do it? I mean, who wouldn't, right? So if you would do it under that analogy, why wouldn't you do that under a building performance scenario where we're working towards preservation of the environment? So let's talk about a little bit more about where some of our other states, our neighboring states, are going with this. So Pennsylvania came and spoke with us, representatives, about where they are. They have some published data, and the data for a structure is similar in size of this. As I said, it's like 59,000. This is like 55,000, 50 units. They're coming in at about 2.75% increase for passive house. And they see an average of 2.7 to 4%. So they're a little bit lower, but they've been at this for a little bit longer. So we're 3 to 5%. In this building that I'm looking at is 4.79. So we're seeing about a 2% increase in cost up here in Connecticut. And I think the same thing holds true for Massachusetts, because I also work up there. So these numbers are coming down. And I think that's primarily because our subcontractors and design professionals are becoming more accustomed to working with these systems, and they're bringing the cost down. You know, in addition to the data that we've just discussed about Pennsylvania, there's some very new data that shows how passive house costs are actually trending down equal or slightly below conventional numbers. And although their square foot cost might be different than ours because of their geographical location, it's very, very consistent. And you can see that by the number of passive house projects certified and built, the numbers are trending down, and ours are trending in line with Pennsylvania currently. And there's no reason to think if we continue along this path, ours will trend down in the same way. So I thought the other reasons why they're seeing this trending down is that, as I said, and we've discussed earlier, that education and training is critical towards a successful passive house project. We're seeing that in Connecticut, which is why our numbers are coming down, and theirs are significantly coming down for the same reason. And I think we'll continue to see ours trend downward because of the new training opportunities that are going to be available to subcontractors and contractors and design professionals here in Connecticut. So again, here up in Massachusetts, they're also looking at ways to promote this. And again, by starting early, the Mass Saves Society up there has funding available to design professionals to do analysis early. So you can get up to $5,000 for analyzing a passive house building early. And I'm talking schematic design phase early in the project. For a 40-unit building, you could get up to $20,000 for energy modeling. That's a big help to clients that are, interested in doing this type of structure. And then there's an additional construction incentive for a 40-unit building up to $120,000 for certification and verification. And that goes a long way to helping clients actually develop this and also work toward a product that is actually going to be saving cost. So to kind of recap why we should choose passive house design. So first of all, we're lowering our operating expenses. Average of 90% less heating and cooling. This is very documented evidence out there. We have a lifetime savings in energy costs that really needs to be factored into the pro formas of these buildings, which is not being done right now. And what we're doing is we're looking for that nice sweet spot in optimizing the envelope and system and spending our money wisely on components that will last instead of things that will wear out and need to be changed quickly. So we have continuous ventilation. So we're creating a very healthy environment and a healthier environment, something that I know we are all too aware of since March, when we've all been dealing with a completely different way of living and considering our interior environments, where air quality has become so critical. Passive house is doing this. It's something that we need to work harder on to apply to our structures. And thermal comfort, as I said, we're emphasizing the envelope. And we're not forcing heating or cooling at the glass lines, right? Our glass is strong, stable, it's high efficiency, and you can sit next to those windows on a very hot or cold day and not be affected on the inside. So you don't have to run away from your windows in the middle of the winter time when it's cold, because you have good thermal comfort. And you're providing a very high performing structure, as I said, with the materials and the systems that we are designing. And once again, you need to work with a qualified team starting at the beginning, and this will always save you cost and always save you money in the end result. So with that, I'd like to thank you very much for listening to this presentation on cost benefits and the beginning of the business case for passive house. And I would certainly be available to answer any questions that you may have. Thank you very much.